Vectors. Learning objectives. By the end of this section you should be able to calculate the magnitude of a vector, find missing values from vectors given the magnitude. Vector A equals 4, 3. The magnitude, the length of a vector A, is written as this. So it's an A with a straight line either side of it. From the column vector, we know the movement along the x and y axes. So the x movement is 4 and the y movement is 3. The x and y axes are perpendicular, meaning this is a right angled triangle. The magnitude of A is the length of the hypotenuse of the right angled triangle, meaning the magnitude of A is calculated using Pythagoras' theorem. So A squared plus B squared equals C squared. So here we have 4 squared plus 3 squared equals the magnitude of A squared. So the square root of 4 squared plus 3 squared is the magnitude of A. So if we simplify that, we have the square root of 16 plus 9 equals the magnitude of A, which gives us the square root of 25, which is 5. So the magnitude of A is 5. That is, the length of A is 5. Vector A equals 6 minus 4. Calculate the magnitude of A. It helps to draw a sketch of the right angled triangle formed by the vectors. Again, note the direction here. So we've got a right angled triangle, which is 6 minus 4. The magnitude is not affected by negative x or y components. So as we've said, the vector's got two components, a magnitude and a direction. So the length of it doesn't matter whether that 4 was going up or down, it's still going to be the same. So A squared plus B squared equals C squared. Magnitude of A squared is 6 squared plus minus 4 squared. So we now calculate this, which gives us the square root of 36 plus 16, the square root of 52. What we should be doing now is thinking thirds. So the magnitude of A is 2 root 13. So it's a non-calculator exercise. So what I'd like you to do, go through here, work out the magnitude of the vectors. Once you've done that, come back and check the answers. If you really get stuck with the surds, if you work it out, if you can't simplify the surd at the end, as long as you get to that point, we'll class that as a success. So pause the video now and do that. So question 1 is 10, 2, 15, 3, 13, 4 is 2 root 10, 5, 7 root 5, 6, 4 root 13, 7, 2 root 17, 8, 5 root 5, 9, 2 root 17, 10, 4 root 5, 11, 2 root 34, finally 12 is 5 root 10. So we'll quickly recap squaring surds. So the rules for multiplying surds. We have root A times root B is root AB. C root A times D root B is C times D times root AB. So looking at some numbers here. So root A squared equals root A times root A, which equals root A squared, which equals A. So if that looks a bit confusing, we'll go through it using the law of indices. So root A squared is, well, the root A is A to the power of a half, and the squared stays there. So if we combine the law of indices, a half times 2 is 1, so that would give us A to the 1, which is A. So we can see how root A squared equals A. C root A squared, and that gives us C squared times root A squared. From the previous one we know that root A squared is A, so that gives us C squared times A. So look at some numbers here. Root 3 squared is 3. Five root 2 squared is 5 squared, which is 25, times root 2 squared, which is 2. So 5 root 2 squared is 25 times 2 equals 50. So quickly go through these, pause the video, shouldn't take you long, but we have to get a bit of practice in this before we move on to the next set of questions. Hopefully not too much trouble for you. So question 1, 2, question 2, 7, 3 is 6, question 4, 18, question 5, 75, 6, 52, 7 is 44, 8 is 98, and that should be question 9, not 6, is 338. So A equals x8, the magnitude of A equals 10. Find the value of x. So sketch the vector and annotate with the known information. So if we look at this, the question may look a bit confusing, but actually when we look at what we're doing, it is again very simple or very straightforward Pythagoras theorem. So 8 squared plus x squared equals 10 squared. X squared equals 10 squared minus 8 squared. So x equals the square root of 10 squared minus 8 squared, which gives us the square root of 100 minus 64, which is the square root of 36, which is 6. So x equals 6. S, vector S is 9y. The magnitude of S is 3 root 13. Find the value of y. It's the same as we did before, it's just now we're involved in surds. So it's not necessarily more difficult, it's more complicated, there's more scope for making mistakes. So what we did, trick to this, is really taking your time and being careful. Sketch the vector and annotate with the known information. So there's our vector. We know that hypotenuse is 3 root 13, we have a side length of 9, and one of the shorter sides is missing. So now we're going to use Pythagoras to work out the value of y. Well, we know that 9 squared plus y squared equals 3 root 13 squared. So we're going to move the 9 to the other side to isolate the y. So we now have y squared equals 3 root 13 squared minus 9 squared. You could have, if you wanted to, sorted out that 3 root 13 squared, get rid of that, turn it into a number and work through it from there. But here, so take the square root of both sides, and we know that y equals the square root of 3 root 13 squared minus 9. So 3 root 13 squared, once you've sorted that out, gives you 117 minus 9 squared, which is 81. So we have the square root of 36, which equals 6. So we now have the length of y is 6. Vector v is 8y. V equals y root 5. Find the value of y. So the mathematics in this is exactly the same. It's just the position at y is just making it slightly more complex again. So again, the trick is take your time, do things very slowly. So sketch the vector and annotate with the given information. So our hypotenuse is y root 5 with one short side of 8 and the other short side is y as well. So first thing we do, use Pythagoras to just write out the equation. I know that 8 squared plus y squared equals y root 5 squared. What we should be thinking now is there's two variables here. So how am what strategy am I going to use to solve this? If we've got two variables, get them all onto the same side. One of two things is going to happen, and we don't know at this stage, not until we've worked it through. But that equation is somehow going to reduce to a quadratic, or we'll be able to combine those two y variables and get rid of one, or just reduce them to 1. So we've got 8 squared equals y root 5 squared minus y squared. So 64 equals 5y squared minus y squared. So just by working through this, we can see this is actually it's going to be slightly easier than we thought. So we combine that. 64 equals 4 root 4y squared. Divide both sides by 4. So now we have 16 equals y squared. We can either subtract 16 from both sides and use the difference of two squares, or take the root of both sides. Using the difference of two squares probably, well, it wouldn't be the easiest option this, because we're going to end up with two solutions for y. But here we're going to take the square root of that, so we have y equals plus or minus 4. From our sketch, we know that y is a positive value. It's actually a length. So you can't have a length of something of being minus 4. It can't be minus 4 long. So y equals 4. So some of these are very tricky, and what you have to do is take your time, go through them slowly, and the chances are you'll have to go through some of these quite a few times until you can work through them confidently. These are grade 8 questions. They're meant to be difficult, but nothing that's beyond you. So take your time, do it slowly, and be prepared to make mistakes and have to do it quite a few times until you become confident. So go through this. Once you've done it, come back, check the answers, and then we'll go through it. So, question 1, x is 6. Question 2, x is 12. Question 3, x is 8, 4, x equals 10, 5, x equals 2 root 3, 6, x equals 3, 7, x equals 4, 8, x equals 6. So if you struggled with any of the questions in this video, work through it again. You must be competent and confident with the content of this video before you move on to the next one. With especially the last questions, they are quite challenging. Don't expect to be able to do it straight away. You will have to go back over them. And it is a good idea, you know, if you are struggling, once you know the answers, it's still worth going back and doing them to see if you do end up at the right answer. So hopefully you found that useful.